All right, everybody, we are looking at the 3-8 notes, looking at quadratic functions in standard form. You'll remember from the previous lesson that a quadratic function, that just means that your largest term in y equals whatever's on the other side, y equals something, your largest term is x squared, okay? That x squared is the key thing that is the defining characteristic of what makes it a quadratic. So when I look at this equation right here, ax squared plus bx plus c. This right here is a lot more common type of quadratic expression than you see what we looked at yesterday. Okay. In fact, when we were doing a bunch of factoring and stuff earlier on in this 6 weeks, when we were doing a bunch of factoring, this is what it looked like most of the time, was something like this: ax squared plus bx plus c. Okay, and a lot of times we'd be looking for those two key numbers, something that multiplied up to C, added up to B. Okay, we'll be doing a bunch of stuff like that. We'll get into that later on. But right now, we're just looking at the definition of what these things look like as functions. Okay, so if you've got y equals 2x in these examples right here, you would say that a, this coefficient attached to x squared, is 2. Now, you would also say, looking at this one, that b and c are equal to 0. Okay, because this one right here, you don't have any x term and you don't have any constant number added at the end. So it's just 0. All right, a is 2, but b and c are both 0. You look at this middle one, negative 3x squared plus 14. You have an a coefficient. A is negative 3, but you don't have an x term. So you would say that b equals 0. And then at the end, you've got this constant number at the end. You would say that c is positive 14. This last one at the end, y equals x squared plus 5x plus 6. Okay, x squared plus 5x plus 6, you've got an a coefficient of 1. Okay, remember your understood 1 out in the front of anything. You've got a b coefficient of 5 and a c constant added at the end of positive 6. Now let's talk about some of our key features. Okay, you'll remember yesterday that we talked about quadratic functions, and we said that they all make a curve that basically looks like this. What I've got on the calculator right here is called a parabola. Okay, that curve shape's called a parabola. And if a is positive, if that coefficient in front of x squared is a positive number, it will open upward, just like this one. Okay, it'll open up instead of the alternative like we looked at in that previous lesson, opening down. If you have a negative number out in front of your x squared, it would look like this. You'd have your x squared and then your negative x squared. It would be flipped over upside down, reflected over that x-axis. Okay, so opening up and opening down are the two options there. Make sure you cross out that positive and replace it with negative. That's just a little typo. Okay. The axis of symmetry we talked about a little bit yesterday. The axis of symmetry is the vertical line that cuts the parabola in half. Okay, so the vertical line that cuts the parabola in half, it goes right through the vertex point, that turnaround point, either at the bottom or the top of the parabola. Unfortunately, the way that we did it in the previous lesson was that you could just look at the numbers in the equation and you could figure out where the vertex was, and then you could just use that x coordinate, and that was the axis of symmetry also. Well, unfortunately, this setup of an equation, y equals this format, ax squared plus bx plus c, there is no way to just look right at the numbers and immediately know what the coordinates of that vertex are. So to find the axis of symmetry, we have to use this formula right here. Negative b divided by 2a. Okay, and what we're doing is we're literally going to take the b out of the equation and the a out of the equation and put them into this formula right here. Okay, finding the vertex is also a bit of a process. Okay, when you're dealing with a function in this format instead of the one that we did yesterday, you can't just look at these numbers and automatically know where the vertex is. You have to first find the axis of symmetry, and we know, just like we talked about before, that the axis of symmetry and the vertex have the same x coordinate. So if we find this number, whatever we get for the axis of symmetry, is also the x coordinate of the vertex. Okay? To find the y coordinate of the vertex, you have to take that number and plug it back into your original ax squared plus bx plus c. Okay? And we'll do some examples that show you what that looked like. The last thing that we're going to be looking for on today's problems is the y-intercept. Okay? The y-intercept of course, is where the parabola crosses the y-axis. We've heard that term before, the y-intercept. When you're looking at it on a function like this, you need to know that the y-intercept is equal to that constant number at the end. Okay, here's how that works. Okay, look at this graph right here, just on an example graph. If I graphed a point up here, okay, that would have the coordinates of 0, 5. This point right here in the middle, the origin, 0, 0. If I graphed a point down here, it would have an x coordinate of 0, y coordinate of -3, just for example here, okay? All of these things have the same thing in common, and that is the x value equals 0. Well, if the x value equals 0 in this function, if the x value equals 0 in this function, this term turns into 0 no matter what a is. This term turns into 0 no matter what b is. The only thing you even have left is the constant number c at the very end. Okay? So no matter what, your y-intercept always equals c, that constant number. Okay? So for all of these problems that we're doing today, and all of your homework problems are going to work the same. You need to identify what are a, b, and c in the function. Which direction does the parabola open? Where is the axis of symmetry? Where is the vertex? Where is the y-intercept? All right, some of this is going to actually end up going pretty quick and easy, and the part that doesn't go quick and easy is still not going to be that bad because you're just plugging into formulas. Okay, so a, b, and c is usually pretty simple and easy to find. Okay, we look at that equation. We know that a is the coefficient attached to x squared, so that's going to be 1, the understood 1. B is the coefficient attached to x, and that's 4. C is the constant number at the end, and that is also 4. Okay, we look at A, and we see that A is a positive number, so we know this parabola is going to open upward. We also look at C, this number at the end. We just got finished saying that C, the constant number, is going to be the same as the y-intercept, so our y-intercept, we automatically know, is going to be 4. These two right here in the middle, the axis of symmetry and the vertex, are going to be your harder things to find, okay? But really, like I was saying, it's really not that bad because all we got to do is plug into that formula. Negative b over 2a is your axis of symmetry. It's always the vertical line at that value. So if I'm looking at negative b, well, that's going to be -4. B is +4, so negative b is -4. And 2a is just 2 times 1. So I just have to ask myself the question, what is -4 divided by 2? Well, that's just -2. So that means our axis of symmetry is a vertical line, x equals -2. Now we also know that the axis of symmetry always goes directly through the vertex. So they have the exact same x coordinate. So right there, if x equals -2 is your axis of symmetry, you already have half of the vertex. The other half of the vertex comes from plugging that -2 into the original equation that we started with. Okay, what we're going to do is we're going to plug in -2 squared plus 4 times -2 plus 4. That's what we're going to do with it. Okay, here's what I've got. This is something that you may want to do in the calculator. Okay, I've talked about this before. I've done math. I have been doing math and multiplying positive, negative numbers for longer than most of my students have been alive. And I still mess up negative numbers when I'm multiplying and adding and subtracting sometimes. Okay, so when you're putting stuff into the calculator, here's what you need to be careful with. Okay, look at what happens if I type in -2 and then hit the square button. Okay, we know in our heads, before I hit enter on this, we know in our heads that a negative number times a negative number gives us a positive result. Okay, so in your head, you're thinking -2 times -2 should be +4. But look at what the calculator gives you. When you just put it this way, it tells you that it's -4. Okay, now we know in our heads that that's not right. But if we had a bunch of other stuff also typed into the calculator, you might not even be thinking about it. Okay, so here's what we need to be careful with. What you need to watch out for is anytime you're dealing with negative numbers, substituting negative numbers into the calculator, into an expression in the calculator, you need to use parentheses. Okay, because if you do it like this, -2 inside of parentheses squared, that's going to give you the right answer of positive 4. Okay, so when we plug all of this in, I'm going to use parentheses as much as I possibly can, just so the calculator absolutely knows, with no way to mess it up. The calculator is absolutely certain of what I'm trying to say. Okay, y'all have to realize that these calculators are not actually smart. They are only able to do exactly what you tell them. And so if you accidentally type in something wrong, it doesn't know what you mean. It only knows what you like, exactly what you said. Okay? So when I type all of that in, including the parentheses, we get a result of 0. And since this thing is equal to 0, that means the y coordinate of the vertex is 0. All right, and that's what we've got, -2, comma 0. Roll on over to problem number 2. Problem number 2, you can see you've got a negative sign out in front of there. That means A is -1, B is -2, C is positive 3. If we're looking at all of those numbers, A, B, and C, we know that this parabola is going to open downward. Okay, this parabola is going to open downward because of that negative sign. And we know because of the C, that constant number at the end, the y-intercept is going to be positive 3. Now, the axis of symmetry, we're always following that same formula, negative b over 2a. Well, negative b, look at b, it's already a negative number, right? So if we're taking the negative of -2, that's going to be positive 2 on top. And on bottom, we've got 2 times -1. So we just have to ask ourselves, what is 2 divided by -2? And the answer, of course, is -1. So that means our axis of symmetry is the vertical line x equals -1. The vertex has the same x coordinate as the axis of symmetry. So we know that's -1, but the y coordinate on the vertex, we got to plug it back in. Okay, this is where a problem like this in particular is where the parentheses in the calculator are your friend. Okay, -1 squared -2 times -1 plus 3. That right there, if you were trying to do something like this just off the top of your head, it is so easy to mix up your positive and negative signs. Okay? Use the calculator and use parentheses to your advantage. Okay? -1 squared -2 times -1, and then plus 3 there at the end. All right, we hit the enter. That gives us an answer of 4, and that means the y coordinate is positive 4. Now, I want to show y'all what this parabola actually looks like in the calculator to see, just kind of check your work and see what it looks like. Okay, so this function y equals -x squared minus 2x plus 3. Okay, and we're expecting the vertex to be at -1, positive 4. We're expecting it to be an upside down, opening downward parabola, which it is. We're expecting the y-intercept to be at positive 3, which looks about right. It's kind of hard to tell, but I think that's right. We're expecting the vertex to be at -1, 4 up here. That looks about right. And our axis of symmetry that goes through there should line up with -1, which also looks about right. Okay, so that's all I'm saying is that I'm not pulling these numbers out of thin air. They really do work and they really do fit this function when you look at the graph of it. Okay, so let's move on. I actually want y'all to take a stab at number 3 on your own. Just take a minute right now. Take a shot at number 3 on your own. You can pause the video if you need to, and I'll come back and show you what I got on the answer for that. All right, here's what I got as my answers. Okay, I got my A, B, and C listed off right there. With C equals 3, we know what our y-intercept is. With A being positive, we know that this parabola opens upward. I got my axis of symmetry with -b over 2a. Well, b was already -4, right? So -b turns into positive 4. You plug in 2a, all we end up with is 4 over 2, which is positive 2. Okay, that's the x coordinate of our vertex also. We plug all of that in, 2 squared minus 4 times 2 plus 3, we get a result of -1. Since that right there is equal to -1, well, that must be the y-coordinate of our vertex. So there's your vertex, 2, -1. And I want to show you what this parabola also looked like. You can see it on the graph. We've got a vertex at +2, -1. Okay, it opens upward just like we were expecting. Our y-intercept appears to be at about +3. Sometimes on the little screen it's hard to tell there, but that all looks about right. Okay, for our very last one, some of this is going to go pretty quick and simple. We've got our ABC for -8, +5. We know what our y-intercept is. It's +5. We know it's going to open upwards. Look at your -b over 2a on this one. Okay, -b over 2a. Well, that becomes +8 over 2 times 4. It's just 8 over 8, right? What is 8 over 8? It's just 1. There's your axis of symmetry as x equals 1. All right, we know that is our vertex x-coordinate. And when we plug that in, this one is really nice because you end up just multiplying everything times 1. Okay, we look at what is 4 minus 8 plus 5. What's 4 minus 8 plus 5? It's just 1. Okay, so we've got 1, comma, 1. That's your vertex. All right. All of your homework problems, again, look just like this. Pretty similar to the previous lesson. All your homework problems look just like this. All right, so if you're having trouble still, let me know, and we'll figure it out, okay? That's all we've got for this section of notes. Y'all have a good one.